This is the quick check on page 110. We have a ballistic pendulum which is hanging and is going to be struck by this bullet. As a result of that, it's going to lift into the air by some value delta H. I know that the potential energy is converted into kinetic energy. So mg delta H is equal to mv squared over 2. We can cancel out the masses because they appear twice. And we can use this to figure out what the velocity is. Velocity is going to equal the square root of 2 times g times delta H. Plug our numbers in there. 2 times 9.8 times the change in height of 0.08, and we get 1.25 meters per second. That is not the mass. That is not the velocity of the bullet. That is the velocity of the block of wood after being hit by the bullet. 1.25 then times 2 kilograms is equal to the mass of the bullet, 0.005 times v. Solving, we get v is equal to 500 meters per second, velocity of the bullet. In question number 2, we're designing the pendulum. This time we use the same formula. We know that the mass of the bullet, 6 grams. We know the mass. Sorry, we don't know the mass of the pendulum, but we know that the bulb rises 3 centimeters. So I'm going to use the fact that, again, v is going to be equal to the square root of 2g delta h, just like that. So 2 times 9.8 times the change in height. It says I want to make it rise 3 centimeters, so 0.03 gives me 0.24 meters per second. That is the velocity of the block. I want to know the bullet. So I need to find the mass of the bullet. 0.006 times 600 600 meters per second. That's for the bullet. And then the speed of the block, but I want the mass of the block, so 0.24. Mass of the block works out to be 15 kilograms. And question number 3. A 56 kilogram boy jumps down from a 2-meter high ladder. Using only the law of conservation of mechanical energy, determine his kinetic energy and his speed when he is halfway down. mg delta h is equal to mv squared over 2. So 56, let's just keep the mass this time. 56 times g, 9.8, times change in height, which is 1 meter, is equal to his kinetic energy. I'm going to put it down here. 56 times velocity squared, which I don't know, over 2. Set these two equations equal to each other and solve for v. You will get that v is equal to 4.4 meters per second.